Hi everyone. We will continue to discuss about stereoisomerism. As you know that stereoisomerisms are molecules with same molecular formula, but they're different in how they arrange in spatial arrangement. I mean, this molecule has different arrangement in space. Okay, there are two stereoisomerisms. It is a geometrical and optical isomerisms. Let's discuss one by one. Geometrical isomerism, known as Cis Trans Isomerism, arise because of carbon around double bonds cannot free to rotate. Okay, that means since there's a restriction because of the presence of pi bonds, around the C double bond C, the carbon cannot rotate as free as in sp3 carbon, in alkene. So that means there will be a possibility of different types of isomerism, in unsaturated organic compounds. In this case, in alkene, it will form a cis trans isomerism. The cis isomerism arises if the same group at the same site. Okay, this is cis. But if the position opposite each other, it arises a trans isomerism. The cis trans isomerisms differ in physical properties. Yeah, the cis isomer usually has the higher boiling point compared than the trans one. Yeah, since usually in trans isomer the polarity cancel each other, so that's why it will have a lower boiling point compared than the cis isomerism. And also they can also differ in both chemical and physical properties. Yeah, sometimes it is make an internal bonds, such as in 2-butene, I mean put 2 in 1,4-dioic acid. Okay, in the Hinton process of the cis and trans, in the in the cis isomer, they will make an internal hydrogen bonds, while in trans cannot, since the position of COOH here is far away each other, so they cannot make hydrogen bonds. But in cis isomer, you can see there, this is COOH bond, and this is COOH group, and this is COOH group. Okay, since they close each other, the hydrogen here, since it's connected to the very electronegative atom, so it has partial positive charge. Yeah, and also here, this is positive partial charge hydrogen. And you know that hydrogen bonds can form between the electrons pair, the lone pair electrons from a very electronegative atom with positive partial hydrogen. So this is the internal hydrogen bonds formed. Okay, so that means, the chemical properties will be differ with the trans, since it makes cyclic form like this. Okay. One more thing that I should tell you, that cis trans isomer rise because of two characteristics. Okay, let's focus on carbon number 1 here. The characteristics of cis trans isomerisms rise because of the C double bond C, connected to two different groups. In this case, let's say this is the first C double bond and this is the second C double bond. The first C double bond connected to 1Br and 1H differ each other. Okay, once again, cis trans isomerism rise because of the C double bond connected to two different groups. How about the second C? it also connected to two different groups. So first, the carbon double bond should bonded to two different groups. Okay, and then the second, between the first and second group, yeah, should be same. Yeah, I mean should be one group same, yeah, at each other. For example, in this case, we are at the same side. Okay, yeah. So minimum there is one, yeah, minimum there is one same group, yeah. Minimum one same groups between, yeah, C double one C, yeah, yeah, BR and BR at the same group. So this is cis isomerism, yeah. If the same group at the same at the same side, at the same plane, yeah, it is called as cis isomerism. At and if it is at opposite side, it is trans isomerism. Okay, opposite side trans, same side cis. So once again, the carbon double bonds you connected to two different groups, and at least one same group, yeah, from this first C and then the second C. Okay, so let's see here. Do we have cis trans isomerisms in 18, for example? No, yeah, because of this first and the second C connected to same groups, yeah, connected to same groups. So it is not fulfill the requirement for cis trans isomerism. Let's say if I ask you, is there any cis trans isomerism in propene? Is there any? Okay, let's check. Propene can be drawn like this, right? Okay, next, you should focus on C double bond and then make two hands like this. Okay, you know that this is CS2, this is CH, this is CS3, right? Okay, so this how I draw propene, HH. And then for the second C, this is first, this is second, H and CS3. Okay, the answer is there is no cis trans isomerism. Okay, so once again, two same groups at the C double bond not fulfill the requirement for cis trans isomerism. But for the second, this is differ, this is okay, but for the first C, not fulfill the requirement. So there is no cis trans isomerism in propene. How about I ask you if there is any cis trans isomerism in both one in? Again, there will be no cis trans isomerism, yeah, since this is CH2. How about both two in? Both two in. Okay, you can see here this is CH3, this is CH, this is CH, this is CH3. So I can draw the structure of both two in like this: H CH3, H CH3. Yes, there is a cis trans isomerism. This is cis, and if you want to draw the trans one, you just move the CH3 here. Okay, here. Okay, so this is how we identify whether there is cis trans isomerism or not. Okay, draw this display formula and name of the cis trans isomerism of both two in. I already drew just now. So this is the cis isomerism, yeah, cis both two in. This is how you give name. Okay, name. This is trans, butuin. Okay, let's try. Pause the video. Okay, let's discuss about this. Is it true for number one? If it is a pair of cis trans isomer, what must be the same for P and Q? This should be correct, right? For example, butuin. Yeah, they should have the same empirical formula, same functional group. How about the skeletal? Okay, the skeletal will be differ. Yeah, since once again, let's see cis trans isomer in butuin. Okay, for example, this is the cis isomer. Yeah, you can see that this will be the first C, the second C, this is the third C, and then for the okay, sorry, I moved this to this. Okay, this is the cis one. Okay, at the same side. Yeah, and for the trans, yeah, you can draw like this. Okay, so differ skeletal formula. Okay, this is cis, this is trans. Look here the position. Cis, this is trans. Okay, so the correct answer is B. 1 and 2 are correct. Okay, let's try this. What's your answer? Is it 2? The correct answer is 3. How I get 3? Okay, let's draw C2H2Cl2, C2H2Cl2. So there is one double bond here. And how I make the Cl, the Cl bond, it can be here. Yeah, 1,1 dichloroethene, right? 1,1 dichloroethene. Or I can move to the second one to give 1,2 dichloroethene. Okay, sometimes you stop here. Okay, so you will assume there are only 2 isomers. But actually, if you okay, so yeah, should be like this. Yeah, too many bonds just now. Okay, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay. Okay, so if you see clearly for 1, 2 dichloroethene, there is a cis trans isomerism, right? So we can draw like this. Since the C double bond connected to the two different group, H and Cl, F and Cl, we can draw the cis 1, 2 dichloroethene and trans 1, 2 dichloroethene. So how many isomers can exist? There are 3. Yeah, 1, 1 dichloroethene, cis, and trans. Since they are differ, yeah, so you should count each of them. So there are 3. Be careful. Okay, cis trans isomerisms also occur in cyclic isomer, in the cyclic molecule. You can see in the cyclic molecule, the cis isomer rise if they have the same plane. Yeah, and for trans, you can see the position of X here, one above and one below the cyclic ring. This is cis. This is trans. Okay, so once again, cis trans isomerism also occur in cyclic molecules. This is the example for cyclopropene. Yeah, cis 1, 2, the dimethyl would be like this, and trans would be like this. In cyclobutane, for cis and trans would be like this. You can see.